about scatter plots. A scatter plot is a graph that is where you have a bunch of points that are plotted on a coordinate system, usually in the first quadrant, and the data that's represented by these points usually has two pieces of information tied to it. For example, this graph on the right is a graph from places in Nevada, where it talks about what is their elevation in meters above sea level, and then what is their average temperature. As you notice, the higher up these locations are in elevation, the lower their temperature, which is kind of what you would expect to see. So that's the kind of graphs we're talking about when we have scatter plots. So let's try a couple of other ones. Here's one where we're actually going to make our own little scatter plot. This data in this chart, this XY chart, relates the hours spent watching TV with the hours spent doing homework. So for our first person, they spent 1 hour watching TV and 13 hours doing homework. So we go over to 1 and up to 13 and make a dot to represent that. Second person, they watched TV for 3 hours, and then they managed to go up and do homework for 10 hours. The next person, 6 hours of TV watching and 8 hours of homework. They figured they're going to have a balanced lifestyle or something like that. So then you got 8 hours of TV watching and 5 hours of homework time. 9 hours of TV watching, 3 hours of homework time. You kind of notice a correlation here, huh? 10 hours of TV watching, 2 hours of homework time. You notice that the number of hours of homework really drops the more someone watches TV. Kind of crazy, isn't it? All right, so there's a basic scatter plot. A lot of scatter plots have many more data points on them. They might ask a lot more people instead of just 6 students, as there is in this case, the same question, and so you get a bunch of dots on here that represent that. Okay, next. Now, as we mentioned, these data points are tied to 2 different sets of data. So the data across the bottom, which we were just looking at on one of the graphs for elevation, was kind of an independent variable. So the x values in our data is called independent data. And so that data where we just picked different locations depending on elevation. Now the temperature, on the other hand, was dependent upon the elevation of that location. So the y values are considered to be the dependent data. And as we go through our discussion, you can kind of watch for that kind of a relationship to show up. Okay, so something else to notice, that when you're making a scatter plot, if the data has a tendency to climb as you go to the right on your chart, that's considered to have a positive correlation. On the other hand, if the data has a tendency to trail downward or drop off as you go to the right, that's considered to have a negative correlation. And then maybe you can remember when we were talking about graphing, this also kind of looked like a positive slope. This looks like a negative slope, and we'll see more of that as time goes on. When there's something positive going on, the data has a tendency to be agreeing with each other. Where you have a negative correlation, the data has a tendency to kind of oppose each other. So that's another way to look at it. All right, so in some cases, when you plot some data, there's no real pattern or rhyme or reason about it, like in these 3 cases. These are all considered to be no correlation cases, where the data doesn't appear to be showing any correlation between the 2 types of data. All right, sometimes the data is really loosely clustered in your scatter plot, like this one, called loose clustering. Sometimes the data is more concentrated in a more narrow region. That's called tight clustering. And sometimes the data almost lines up in a line like this. That would be perfect clustering, or Another word that we used earlier in the year was a linear relationship. Now you also notice there's a couple of dots that are way off to the side here. Those are called outliers. They're points that have a tendency to be way above or way below the existing set of data. And unfortunately, when we're using data and try to analyze it, we have a tendency to disregard the outliers. And so sometimes that seems kind of sad. And sometimes that seems to happen in real life, doesn't it? If someone's kind of an outlier, they kind of get ignored, and that's not good either. We need to value everyone. Okay, so here's some other examples of what we call clustering. And sometimes the data can be clustered into different groups. And so this clustering has some gaps in between. So you might be able to note that and see why that might be taking place in whatever particular application that you're trying to graph. All right, now if the data has a tendency to cluster along a fixed line like this one does, either up or down, that's considered to be a linear correlation. If the data has a tendency to kind of cluster along like this, but then curve and go back over, so that it's not a straight line, that's considered a nonlinear clustering, okay, or nonlinear correlation. All right, so let's practice a few. Which scatter plot shows no association? Well, it turns out that A is one that shows no association. Okay, which show a positive correlation? So I'm going to say, as I look at these a little bit more, I think I'm going to add B to the list of one that shows no correlation. And A is pretty close to no correlation, but it could almost be a slightly positive. But C, on the other hand, is a much more positive. F is looking pretty positive here. So you're going to see that data goes up as you go to the right. H, even though that's not perfectly linear, it does appear to be going up as you go to the right. Meanwhile, the ones that show a negative correlation would be like D. It kind of angles down as you go to the right. E is kind of a non-linear, but it is a positive at one point and negative at another, so we'll kind of ignore that one. G has a pretty good negative correlation as well. Okay, number 3, which show a linear association? So if you look at the ones that actually line up on a pretty good line, that would be C. Oops, put that up here, C. And then D also looks linear. F is close to being linear, but not super clustered up. And even G, you could almost kind of imagine a line going in there. And H is close. It's almost a little bit between. Now, if they're nonlinear, of course, A, unless you're going to call that positive, which is pretty big stretch there. B is nonlinear. E has got a curve on it, so that would be considered nonlinear as well. Okay, and then which ones have a tight clustering, A or C? Well, C does. Look at that. You have a pretty good clustering right along this line. A is a little looser clustering. It's it's tighter than B, but certainly wouldn't be considered a real tight clustering. Okay, so something you might see on ALEKS is some questions like this. Which data set appears to show a negative relationship between the two variables? Well, we mentioned as the data kind of drops as you go to the right, that's considered negative. So figure 1. Which data set appears to show a positive linear relationship? Well, definitely this one does. Figure 3. Which data set appears to show a nonlinear relationship? Well, here we go. Where it kind of goes up and down. So nonlinear. That's 2. Sorry. And then the last one, which data set appears to show no relationship? No relationship there on figure 4. So, okay, so that's kind of one of the types of questions you might see on an ALEKS assignment. Okay, here's another one. Shown below are scatter plots for 4 data sets. Answer the questions. Choose the 2 data sets that have outliers. Okay, so this one has an outlier, and this one has an outlier, so that would be figures 1 and 4. Figure 1 and 4. Okay, choose 2 data sets that show clustering. Okay, shows clustering. Okay, so it looks to me like figure 3 definitely shows clustering. And somewhere, figures 1 and 2 are going to be clustered along the line. I'd say figure 2 probably has a better example of clustering because the points are kind of clustered around each other just slightly more than they are in figure 1. Okay, keep her going. All right. Here's a couple of questions related to independent versus dependent variable. So what is the dependent variable? What is shown on the y-axis? Well, that would be test scores, right? Test scores. All right, so if that's the case, what is the independent variable? Well, that is sleep. How many hours? You get to decide how many hours of sleep. Is there an association with this data? Does the data appear to be going anywhere as you go to the right? Yes, it appears to be a positive correlation. If there is it linear or nonlinear? They're kind of clustered up on a general linear pattern, so I would say linear. If linear, is it positive or negative? And it is going up as we go to the right, so that would be positive. So to describe the relationship in your own words, the more hours of sleep that you get, and if you get good rest, you have a tendency to get better test scores. Okay, so moving on to the next one. Okay, identify the data sets as having a positive, negative, or no correlation. Okay, number of years a person went to school and their income. So if a person got a lot more education, were they more likely to make more income or less? I think most of the time they would get more income, so positive. The age of a house and the number of people living in the house. There shouldn't be any correlation with that. Okay, the number of weeks a movie has been out and the number of people attending the movie. So I would guess that would be a good positive one because the longer the movie's been out, the more people have attended the movie. So that's one way to look at it. The other way to look at it might be on a daily basis. If a movie first comes out, lots of people go and see it. But the longer it's been out, the fewer and fewer people have a tendency to go see it. So the number of people going to the movie might drop as well. So this one, you have to kind of define how you want to show the data. All right, the scatter plot shows the weight and fuel efficiency of 25 vehicles as shown in a line of best fit for the data. And lines of best fit we're going to do a little later on. But first of all, for these 25 vehicles, as weight increases, what happens to fuel efficiency? So we notice as the car gets heavier, it goes fewer miles per gallon on a tank of gas. So what happens to fuel efficiency? It decreases, all right? So if it decreases like that, then for the 25 vehicles, there is a negative correlation between weight and fuel efficiency, right? The bigger the car, the less the mileage you get. Using the line of best fit, would you predict that a vehicle weighing 3,000 pounds would have a fuel efficiency approximately how many miles per gallon? Okay, so that's something that you could come up with. For example, if you looked and you said, okay, let's try to pick a data point that's right close to the line here, like this one. So at about 2,750 pounds, you get about 31 miles to the gallon. So fuel in miles a gallon. So somewhere So let's go to 3,000 pounds. You go up to 3,000 pounds. That's going to hit the line right there. So it looks to me like if you have a 3,000 pound vehicle, you're going to get around 30 miles to the gallon. So again, to do that, you just draw a line up from 30,000 and then turn and go to the left until you hit the line on the left side. So it might be a little more than 30 gallons, but right in that area. Okay, so those are the kind of assignments or questions you can expect to see. And so there's your assignment. It's on Alex. Good luck.